Hello everyone, and welcome to this week's Armagh Astrobytes, where we take astronomy and break it down into bite-sized chunks. We're joined again by Professor Michael Burton, who is the director of Armagh Observatory and Planetarium. So this week's topic is all about galaxies. So last week we heard about our own galaxy, the Milky Way. Are we alone, or are there other galaxies?
Well, Courtney, it turns out that the universe is full of galaxies. And we're going to talk a little bit about that this week. And we're going to start by looking at this picture here, which is really our big brother, our Milky Way's big brother. It's the Andromeda Galaxy. It's another star city with 100,000 million suns. It turns out that the Andromeda is about twice the size of our galaxy. It's about 2.5 million light years away from us. But essentially, it's another galaxy, one of many, many galaxies in our universe.
Okay, and how was the first external galaxy found? So the first galaxy that wasn't our own?
Yeah, so the question of what the Andromeda Galaxy is and the fact that it's actually external, a long, long way from our Milky Way, marks the culmination of a grand story of discovery in astronomy. And it starts here. It starts here in Ireland with this remarkable telescope called Leviathan, which was built at Birr Castle by the Earl of Ross in the mid-1800s. And this was the biggest telescope in the world for roughly 75 years. And the Earl of Ross worked with Romney Robinson. Romney Robinson was actually the third director of Armagh Observatory, and they used this remarkable telescope to peer into the cosmos and essentially take pictures, better pictures than ever been taken before. Of course, they weren't actually pictures because the camera wasn't invented then. They were actually sketches and drawings. And this particular drawing up here shows an interesting object which they discovered and trying to understand it.
So what is this spiral nebula we can see here?
So that was the big mystery, trying to understand the nature of this spiral nebula, because that's essentially what they saw. The fact that this one here, the first one, they called it the Whirlpool Galaxy. Well, it's called the Whirlpool Nebula, I should say. Later on, the term galaxy came in. It was actually the object Messier 51 from Messier's catalogue. And when they looked at that, they started to see this remarkable spiral structure in there, which no other nebula had been seen to that date. A modern picture of the same region is shown here. In fact, it's now what we call a galaxy. And you can see it's remarkably similar to the sketch that the Earl of Ross made in the 1840s, standing in the dark on top of a ladder, I think 60 feet high in the air, sketching it in the dark. But it's really what we now know is it's a city of stars. But in fact, Robinson and the Earl of Ross didn't know then. In fact, observing this sparked a great debate. What is actually going on? Were they full of stars? Could they be resolved? If they had bigger telescopes, would they turn out to be nebulae full of stars? They actually thought they had resolved stars at the time, but it turned out they hadn't. The telescopes weren't good enough, but there was a great debate which this led to.
So how was this debate resolved? How did they know that they were looking at another galaxy?
So I'm now moving forward. Actually, it's another 75 years since the discovery. It was actually unknown what the real nature of these objects were for many, many years. And it took there's a famous occasion in 1920 called the Great Debate, and two of the great astronomers of the day, Harlow Shapley and Heber Curtis, essentially analyzed the evidence for the nature of these objects here and tried to come up with an idea of what they were. Essentially, the debate was about whether these spiral nebulae were really part of our own galaxy, really just nebulae in our galaxy, or were they completely separate objects altogether, vastly further away. And Shapley and Curtis, they both had evidence for and against this. Neither of them was actually completely right, but they both led on to understanding about our place in the cosmos. But the debate was not actually resolved by either Shapley or Curtis. It actually took Edwin Hubble and a new kind of measurement made of stars in that Andromeda Galaxy, which I showed in the first picture, of stars called Cepheid variables, which are a particular kind of variable star, which we'd learnt by the time Hubble made his observations that if you could measure the period of the change in the luminosity, you could actually tell how bright they were. And if you knew how bright they were, then you could work out how far away. And Hubble's work showed that the Andromeda was a very, very long way away. In fact, it was measured in millions of light years away from us. And this made it clear that these spiral nebulae were not part of our own our galaxy, so to speak, and they were island universes, galaxies in their own right.
So we now know that the universe is filled with spiral galaxies, but do they all look the same?
Well, in fact, they don't. In fact, the more we look into the universe, the more we see diversity amongst the different types of galaxies. So, in fact, the spectacular spiral galaxy Messier 51, it's a face-on one with well-defined arms, but it's actually only one type of spiral galaxy. And this picture here shows three types. Going from on the left, we see a spiral which has got very, very smooth. The spiral arms are actually quite hard to see. They're broad, a large central bulge. Going to the right, where the spiral arms are very, very clear to see, well marked out, quite narrow and well defined, and the central bulge where the old stars are is actually quite small. We now know that the spiral arms are actually full of gas and dust, and this is where star formation is actually occurring, and the nature of the spiral arms depends upon the evolution, the history, all sorts of things which are involved with that growth of those galaxies.
Okay, and are spiral galaxies the only kind of galaxies?
And then it turns out that that's also not the case. There's actually many different types of galaxies. The spirals are the most spectacular, and they're the ones which they saw with Leviathan. But in fact, many galaxies are like this. They're elliptical. They're basically rugby ball shaped. Sometimes they can be football shaped, but other times they're very much distorted into ellipses. These ones don't tend to have very little gas. They're mostly just composed of stars, and so little star formation is taking place. But a lot of galaxies in the universe do have this elliptical shape rather than a spiral shape.
Okay, so it's just spiral and elliptical then?
I'm afraid not. Indeed, there's a lot of galaxies in between, galaxies which have irregular shapes, amorphous shapes, which can't readily be classified. And in fact, the nearest galaxies here to our Milky Way are irregular galaxies. This one here, the Large Dimensional Cloud, is in fact the easiest galaxy you can see. If you go to the southern hemisphere, it's up there on any dark, moonless night. You will see this in the sky. It essentially looks like a little cloud in the sky, and that's actually where it got its name from the Portuguese explorer Magellan, when he was the first sort of European to sail in that part of the world. What this is an irregular galaxy. It's basically a small galaxy pretty been torn apart by falling into our Milky Way, the gravitation from our Milky Way tearing it apart. It's about 160,000 light years away. It spans about 20 degrees in the sky, so sort of 40 times the sort of size of the full moon. In fact, covers the full extent of this galaxy. Most of it, though, is much more compact than that. But this is a typical irregular galaxy.
Okay, well, we've seen a lot of different photos of galaxies. Are galaxies found alone, or do they sometimes come with other ones?
And indeed, that picture of the Magellanic Clouds actually gives a clue to the answer, because the Magellanic Clouds are, in fact, really bound to our own galaxy. And the more we look out in the cosmos, the more we realize that galaxies are not alone. Galaxies come in clusters. In fact, our Milky Way and Andromeda are really the two largest members of what we call the local group, which is a cluster of relatively few galaxies. There's about 100 or so galaxies in our local group. But in fact, our local group is actually bound to a much larger cluster. It's called the Virgo cluster of galaxies, and we're looking towards the center of it here, two giant elliptical galaxies, Messier 84 and 86 at the center. The Virgo cluster has something like a couple of thousand galaxies to it. And really, it's the start of our exploration of what's called the large-scale structure of the universe, what the universe looks like in the bigger scales, and essentially it's dominated by galaxies.
Oh, wow. So we are by no means alone in our little corner of the universe then.
No, indeed we're not. And that's what we're going to start exploring next week when we start talking about clustering of galaxies and large-scale structure of the universe.
Well, I can't wait to hear more about it, but everyone else will have to tune in next week to hear about it. So thank you, Michael, for talking to us today about galaxies, the different types, and the fact that they sometimes indeed come together. We'll learn more about that next week.
Okay, thank you, Courtney, and see everyone next week.